Everyone, welcome to this fifth lesson of the Forces in Space scheme. This is about contact and non-contact forces, and really that's one of two things that you want to get across during this lesson. So one is the difference between contact and non-contact forces. Two is actually it's about giving students practice at drawing force diagrams and some of the some of the kind of formalism, the rules that we use to draw force diagrams, because that's going to be really important as they progress into genuine physicists. So the first thing I would do is just start by returning to something that we talked about in the previous lesson, this idea of forces and pushes and pulls. And if we go back to a diagram that we drew last time, let's do the Earth, the Earth orbiting the Sun, like this. So what we've got here is the Earth orbiting the Sun, and again, it's worth questioning, and this is a chance to just revisit this difference between the Aristotelian picture, which some of them might still hold, in spite of having done a lesson on it, the Aristotelian picture versus the Newtonian picture. And some of them might still want to tell you that there's a force going that way, pushing the Earth around, but actually, hopefully they're clear now, and you want them to be clear that the force that's acting is this force of gravity, which we'll come to later, but acting in this direction towards the Sun. And what's important to emphasize, and you might want to question students about this, to say, well, look, what's in between the Sun and the Earth? Space. It's a vacuum. There's no particles, no nothing. So that's kind of strange, isn't it? How can there be this gravitational pull even though there is no contact whatsoever between them? And actually what we're doing here is introducing this really profound idea of action at a distance. And I've actually drawn this force diagram not very well, because it should be starting from the center of the Earth here. But what we want to illustrate when we're talking about contact and non-contact forces is that, yes, there are pushes and pulls, and there's lots of different examples that we'll look at in that regard. But there are also these non-contact forces where there's no connection whatsoever, but somehow objects interact with each other without touching. Now, gravity would be one example of that. Magnets would be another, and they come up later in the lesson. The electrostatic force is another one, but maybe we're not going to go into that in too much detail, because this is just Key Stage 3. And again, we probably wouldn't even look at this until Key Stage 5. There are forces inside the nucleus which are holding the nucleus together and keeping that stable, which are also examples of non-contact forces. But the main two for today's lesson are gravity and magnets. They're two examples of forces where things don't have to touch, but they can still affect one another. Now contrast this with some examples of contact forces. And again, this lesson is really just about giving students some names of common forces. So we'll just do two examples. Maybe we can do Newton's famous tree. So if I draw a very simple tree here, and maybe draw an apple that in the tree, this apple is held onto the tree by one force, which we're going to call tension. So that's a force acting upwards, and we say there's a tension. So anything on a rope, I think bungee jumpers comes up later, so on and so forth. That is a force called tension, and that's a contact force because that relies on there being some object that's holding the other object in place. So in this case, the branch, or the branch of the tree holding the apple up. And then there's this other force. So tension would be a contact force, the force that's pulling the apple down. And what I want to do is emphasize to students, by the way, I always draw my forces from the center of the object. So maybe I've done this a bit small. That's maybe not the best example to do, but I'll draw these from the center of the object with a straight line and a ruler. And I tend to do thick block arrows for forces. You don't need to draw this to students necessarily. I tend to draw velocity as a non-block arrow like that, and then acceleration as a double non-block arrow, if that makes any sense. And it's quite helpful just for organising students' thinking when they're doing more complicated problems, especially when they get to A level and beyond, to have some sort of symbolism like this. So I tend to draw my forces as block arrows, and I always start from the centre. And we don't need to talk about centre of mass at this case, just say start from the middle. Students tend to be happy with that. So that's how we draw forces. So this force, again, you can call it weight if you want. We'll come to that next lesson. If you want to just call it gravity, that's fine. And again, what you want to do is illustrate there's something holding this in place. And if there's not something holding this in place, the apple will just fall down. So that's a contact force. Gravity, there's no attachment between the earth, which is pulling it down, and the apple, so that's a non-contact force. You might just want to do one more, just to test students' thinking. So I think, yeah, I've got a boat in water, so maybe let's put a person in the boat as well. Like that. So here's a boat in water. In this case, if I just draw it in the kind of middle of the system here, well, still got this force acting downwards. Now this way it gets a bit more complicated, but again, we've got gravity, which is another non-contact force. They might get a bit confused here because of gravity, the boat is pushing into the water. And we'll get into Newton's third law, which I tend to skip over at year 8 because it's just kind of complicated. You can just kind of give them the idea of Newton's third law without explicitly telling them. If it's pushing down in the water, well, the water kind of pushes back. And in the case of water, we call this upthrust. And what they need to recognize is that upthrust is a contact force because it's about pushing, the water's pushing back up. What's actually pulling this down, it's nothing to do with the water that's pulling it down, it's really the mass of the earth. So this would be a non-contact force again. And really the rest of the lesson is just identifying contact and non-contact forces, and again you can do a little bit of assessment as learning and show them the pictures and see what they think and challenge them and teach them that way, and then it's drawing lots and lots of diagrams, and really that's about practicing this point. We start from the middle. I tend to draw a little dot. Again, that comes to centre of mass later, but for now I don't talk about that. Just say put a dot roughly in the middle of the object, and then I draw my straight line with a block arrow to do the force. And if you get students practicing that, that's going to really help them for later on in the scheme. In the next lesson, we'll look at this gravitational force, gravitational attraction, in a bit more detail.